So let's just move on further, and now we will discuss the question number 2. The question number 2 says that show that any positive odd integer is of the form 4q plus 1 or 4q plus 3, where q is some integer. Now we have to show that any positive odd integer is of the form either 4q plus 1 or 4q plus 3. So on the same path or on the same way like we did in the question number 1, we have to prove the question number 2. So let's just start the solution set of this particular question. So first of all, we are pointing out the keywords. The keywords, as we know that we have to prove the number is either of the form 4q plus 1 and either it is of the form 4q plus of 3. So in both of these numbers, 4 is the common number. In both of these numbers, we have to prove either the number is of the form 4q plus 1 or either the number is of the form 4q plus 3. So in both of these numbers, the number which is common is nothing but 4. So we can take b as 4 over here. So let's just start the solution. First of all, we have to write let a be any positive integer. So we can write a and b as any positive odd, a and b are any positive integer, and then we can suppose the value of b, or either we can write it in the formation like this. Let a be any positive integer, let a be any positive integer and b is equal to 4. So we can write it as like this, or we can write it like I already wrote in the question number 1. So both of these are correct. So let us suppose I'm taking it as like this. Let a be any positive integer and b is equal to 4. So by Euclid's division lemma. So by Euclid's division lemma, which says a is equal to bq plus of r, where the value of r will always lies in between 0 and b, using this particular result. So let us suppose I'm putting it under a box. Okay, so by Euclid's division lemma, which is a is equal to bq plus r, where the value of r is always lies in between 0 and b, using this particular result, substitute the value of a and b in this particular lemma. So we know that a is again a, but the value of b over here, let us suppose I'm calling it as star, the value of b is nothing but 4. So use the value b as 4 in this particular equation. B is nothing but 4q plus of r with the condition on r that it is lying in between 0 and b. So what is the value of b? The b is nothing but 4. So we have at the last equation as a is equal to 4q plus r with the condition that r is lying in between 0 and 4. Now let's just start with the values of r first. As we know that the value of r is lying in between 0 and 4, so it means that the value of r can either be 0, can be 1, can be 2, can be 3, but it can't be 4 because there is no such equality over here. So the value of r can be 0, 1, 2, 3. So we can take these r values, and after solving these r values, or after substituting all these values of r in this particular question, let's just start with the solution set. So let us suppose I'm taking the case number 1 over here. The case 1 is nothing but, let us suppose I'm substituting the value of r is equal to 0 in this particular equation. Let us suppose I'm calling this equation as nothing but equation number 1. So substitute the value of r over here. So a is nothing but of the type 4q plus r. R means 0. So here a is nothing but 4q of formation. So let us suppose we can write it as 2 into 2q. 2 into 2q formation. So obviously whenever any number do have a factor 2, and it is of the formation this, then definitely it is nothing but an even integer, because the multiple of, or we can say the factor of this number is nothing but 2. It means that this number is nothing but an even integer. So a is equal to 4q is nothing but an even integer, but we just wanted to find out the odd integer. It means this is not the case, or this is not the solution set, because we wanted to find out that the number or any positive odd integer is of the form 4q plus 1 and 4q plus 3. So this number is not of that formation. So we are neglecting the case number 1 because it is providing us an even integer. And we just wanted to find out an odd integer. So let's just move on toward the case number 2. The case number 2. So the case number 2 in which we have to take the value of r as nothing but 1. R is nothing but 1. Now let's just substitute the r is equal to 1 equation number 1. So it will be like a is equal to 4q plus of 1. 4q plus of 1. So obviously we know that 4q is nothing but an even integer, and even plus of 1 will always results into an odd integer. So it means that a is equal to 4q plus 1 is nothing but an odd integer. So odd integer is of the type 4q plus 1. So 4q plus 1 is an odd integer. So the very first condition is all proved over here, that any positive integer is of the form 4q plus 1. Now we have to prove that it is either of the form 4q plus 3. So this is our very first solution set. So let's just move on toward the case number 3rd, and we will see what we will get after solving it. Case number 3rd is when we have to take the value of r as nothing but 2. R as nothing but 2. So let us suppose I'm taking the value of r as nothing but 2 over here. So substitute the value of r as 2 in this particular equation. Again, a is equal to 4q plus of r. The value of r is nothing but 2. So in this particular equation, we can take the value 2 as a common. So let us suppose I'm taking 2 as a common from here. So we will get the answer as 2q plus of 1. So again, this particular number has a factor as 2. It has one of the factor as 2. It means that it is nothing but an even integer. We are not finding out any even integer over here. So this case is actually neglected because we just do not want to find out any even integer, because the question is all about finding out an odd integer. So this is not the case which is in our priority. So let's just move on toward the case number 4. Case number 4. Case number 4 says the value of r should be 3. Substitute the value of r is equal to 3 in the equation. So it will be like a is equal to 4q plus of 3. 4q plus of 3. Now we know that a is equal to 4q plus of 3 if we are talking about. So this is nothing but an even integer. This is nothing but an even integer. And whenever we will add any even integer with a number 3 as odd, let us suppose I'm talking about taking even integer as 2. So 2 plus 3 is nothing but 5, or let us suppose the even integer is 4. So 4 plus 3 is nothing but 7. So it always results into an odd integer. So a is equal to even integer plus of 3 always results into an odd integer. So a is equal to 4q plus 3, which is equal to odd integer. So odd integers are either of the form 4q plus 1 or 4q plus 3 is all proved over here, that any positive odd integer is of the form either 4q plus 1 or 4q plus of 3. So this is all proven at the end, that either the odd positive integer is of the form 4q plus 1 or is of the form 4q plus 3. And the case number 1 and the case number 3 is neglected because both of these cases are giving the answers as an even integer. But we just wanted to find out an odd integer. So I hope the concept of finding out the solution set of this particular question is all clear to you. So let's just move on further.